Hello students, welcome to today's session. In previous session, we learned about refractive index and two types of refractive index, relative refractive index and absolute refractive index. In relative refractive index, we learned to express the refractive index in terms of angle of incidence and angle of refraction, and relative refractive index with respect to one medium is mu2 by mu1, and the relative refractive index of medium 2 with respect to 1 as the speed of light in medium 1 divided by speed of light in medium 2, and the last one, the absolute refractive index in terms of speed of light in vacuum divided by speed of light in given medium. In today's session, we are going to learn about what are the factors affecting refractive index. Some factors will be influencing refractive index, right? Let's check it out. The first one, the refractive index of a medium depends on nature of the medium. Means different medium has got different refractive index. Look at this formula. We know that mu is equal to speed of light in air or vacuum divided by speed of light in given medium. All right. So the speed of light is constant through the air. So when C is constant, surely I can write mu inversely proportional to the speed of light in the medium. So less the speed of light in the medium as compared to the air, more is the refractive index. The speed of light and refractive index is inversely proportional, as it is obvious from this formula. So I can write the speed of light in glass is 2 into 10 to the power 8 meter per second. Alright. So the refractive index of glass is 1.5. Speed of light in water is 2.25 into 10 to the power 8 meter per second. And the refractive index of water is 1.33. So when the speed varies, since refractive index and speed of light is inversely proportional, since the speed is different in different medium, definitely different medium has different refractive index as shown on the board. So refractive index of glass is 1.5. At the same time, refractive index of water is 1.33, which is lesser than the refractive index of glass. For example, refractive index of diamond is 2.4. So diamond is another medium which offers a very high value of refractive index. So I can say that refractive index of a medium depends upon the nature of the medium. First factor. Alright? Yes. Now next, the second factor. The physical conditions such as temperature. So temperature affects the refractive index of a medium. So how it affects? When you increase the temperature, the speed of light in medium increases. So when you increase the temperature, speed of light in medium increases. So as the speed of light in medium increases, the refractive index decreases. The refractive index and speed of light is inversely proportional, as you know that mu inversely proportional to V. Alright. So as the temperature increases, the speed of light also increases. When the speed of light increases, refractive index decreases. As simple as that. See, once again, see, as the temperature increases, speed of the light increases. Both are directly proportional. So then what happens when the speed of light increases? As you know that speed and refractive index are both inversely proportional. When the speed of light increases, refractive index of the medium decreases. Fine? Okay. Now the third factor affecting the refractive index, the color or wavelength of light. Color or wavelength. So please learn all these factors. Based on these factors, board questions could be asked. So color or wavelength. You know, white light is a bundle of 7 colors. White light is made up of 7 colors, or better we say that 7 wavelength. And the wavelength of visible light increases from violet, indigo, blue till red, VIBGYOR. We know the VIBGYOR, the visible spectrum of light. So the wavelength increases from violet to red. So violet has least wavelength, red has maximum wavelength. maximum lambda, or violet has a lambda minimum, I can write. Alright, okay. So the white light consists of 7 wavelength, and the speed of all colors is same in air. So when the light travels through vacuum or in air, all the colors have the same speed, whether it is violet, indigo, blue, yellow, orange, green, red, all the colors have the same speed. But when it enters into a given medium, so different color has different wavelength. When the wavelength changes, what happens? There is a change in refractive index of the medium. Alright. So red has the maximum speed. So I can write that speed and wavelength is directly proportional. Look at this technical points. So more the wavelength, more will be the speed. Alright. So the more the speed and refractive index is inversely proportional. Alright. So the more the wavelength, more the speed. More the wavelength, more the speed increases, and less will be the refractive index. Alright. So as I can write, when a white light passes from one medium to another medium, red light having the maximum wavelength, it experiences least refractive index. So I can write refractive index of violet, refractive index of a medium for violet will be greater than for refractive index of red. Alright, how it is possible? Because red light has the maximum wavelength, more speed, more the speed, less will be the refractive index. So the red light will experience least refractive index, and violet light will experience maximum diffractive index. So I can write definitely from this all these points I can write refractive index for violet is more than that of refractive index of red. So as you go up, the refractive index going on decreasing. So refractive index, as you go up in the visible spectrum of light from violet to red, refractive index decreases. Diffractive index, I can write decreases. Okay, so diffractive index goes on decreasing from violet to red. Okay, so these are the 3 factors: nature of the medium, temperature, and color or wavelength. These are the 3 factors affecting the refractive index of a medium. Clear? Now we are going to discuss an important board question. What are the conditions for a ray to pass undeviated? You have to state 2 conditions for the ray of light to pass undeviated. It's an important board question. Come on, let's try to understand it. The first condition for the ray to pass undeviated, we have studied when a ray of light is falling on a medium at normal incidence, it passes undeviated. For normal incidence, I can write angle of incidence is equal to angle of refraction is equal to 0. So when the angle of incidence is 0 for normal incidence, I can say that the ray of light pass undeviated. Although there is refraction taking place, but we say that the ray of light passes undeviated. We have discussed this case in the topic of relevance of Snell's law for normal incidence. If you haven't watched the video, please watch the backup videos. Alright, for normal incidence, when angle of I is equal to angle of refraction is equal to 0, the ray of light passes undeviated. The second condition is that when the refractive index of the 2 medium is same as that of the first medium. So for example, when a ray of light traveling from medium 1 to medium 2, when there is a change in medium, there is a change in speed of light. So since there is a change in speed of light, the refraction takes place. What happens when refractive index of medium 1 and refractive index of medium 2 are equal? When mu1 is equal to mu2 is equal to mu, say, what happens? So when there is no change in refractive index, what happens? The ray of light passes undeviated. There is no change in refraction. There is no change in the direction of light ray. So when the refractive index of the medium are equal, we can obviously say that there is no refraction taking place and the ray of light passes undeviated, as you can see on the diagram. Alright, so what are the conditions for a ray of light to pass undeviated? For normal incidence, when angle of incidence and angle of refraction is equal to 0, and when the refractive index of the two medium match each other, there is no refraction taking place and the ray of light pass undeviated. Is it clear? Okay. Now let's study the principle of reversibility of light. What do you mean by principle of reversibility of light? The principle of reversibility of light says that light rays are reversible. What do you mean by light rays are reversible? So let's check it out. You know, light travels in a straight line path in the form of beam of light or rays of light. So light ray is traveling in a straight line path. What will happen if you place a mirror in the normal position on the path of beam of light? What will happen? Light rays will get reflected back along the same straight line path. Or I can say that light rays are reversed back along the same straight line path with the help of the mirror, which is reflecting the light rays back along the same straight line path. So this is what meant by light rays are reversible. With the help of a mirror, we can retrace the path of light along the same path. Alright, so light rays are reversible. This is called the principle of reversibility of light. Now let us apply this principle of reversibility of light in case of refraction of the light. And let's check it out. Let's see what happens and what result we get with the help of principle of reversibility of light. So you can see, as you can see on the board, a ray of light traveling through medium 1 with refractive index mu1. It is incidenting at the surface of separation between two media, and it is getting refracted through medium 2 with a refractive index mu2. Alright, and it is bending towards the normal, as refractive index of mu2 is medium 2 is greater than refractive index of medium 1. So medium 1 is a rarer medium, medium 2 is a denser medium, obviously. Now what happens for the refraction? For the refraction from medium 1 to 2, let us see what happens. Let us try to apply the principle of reversibility here. From when the refraction taking place from medium 1 to medium 2. So we can write, I can write the refractive index using Snell's law, refractive index of the second medium with respect to first medium. I can write sine of angle of incidence to sine of angle of refraction. Alright, this is for the medium 1, equation number 1. This is, we have expressed Snell's law, or the relative refractive index of medium 2 with respect to 1, sine of angle of incidence to the sine of angle of refraction. Now what happens? Now the light rays are reversible. When light rays are retraceable with the help of a mirror, the refraction is now taking place from medium 2 to medium 1. So when refraction is taking place from medium 2 to medium 1, let us see how we can write the Snell's law. Very simple. We have learned already, when refraction is taking place from medium 2 to medium 1. How will you write refractive index of the medium 1 with respect to medium 2? How will you write? I can write sine r upon sine I. Just a reciprocal of that. Refractive index of medium 1 with respect to 2. It will get reversed, sine r by sine I. This is equation number 2. Alright? Okay. Now compare this equation number 1 and 2. Comparing equation number 1 and 2, what we get? I can write refractive mu2, refractive index of medium 2 with respect to 1, into refractive index of medium 1 with respect to 2 is equal to sine I upon sine r into sine r upon sine I. Alright, so it get cancelled. So I am getting it as refractive index of 2 with respect to 1, product of refractive index of medium 2 with respect to 1, refractive index of medium 1 with respect to 2 is equal to 1. Alright, so I can write refractive index of medium 1 with respect to 2. I can write 1 by refractive index of medium 2 with respect to 1 from this equation. Alright. So I am taking refractive index of 1 with respect to 2. I can write. So it will go to the denominator part, 1 divided by refractive index of medium 2 with respect to 1. Alright. Or I can write refractive index of, from here refractive index of medium 2 with respect to 1 is equal to 1 by refractive index of medium 1 with respect to 2. This is the mathematical proof to it. So already we have studied in the previous session. So let us check it out how it happens. For example, refractive index of glass with respect to air. Refractive index of glass with respect to air is 3 by 2. For example, how it is applied in the real problem situations. And refractive index of air with respect to glass. So what will be the refractive index of air with respect to glass? So it will be reciprocal of that, 1 divided by 3 by 2, that's equal to 2 by 3. We are getting the refractive index of air with respect to glass as 2 by 3, that is almost 0.67. Okay, so refractive index of glass with respect to air 3 by 2. Then what will be the refractive index of air with respect to glass? Just take the reciprocal of that. Okay, clear? Yes, this is how the principle of reversibility is applied in problem solving situation. Now let's solve an application based on principle of reversibility of light. This is a question for you. You can see on the diagram, a ray of monochromatic light enters from air into a liquid at an angle of incidence 45 degree, and it is getting refracted through the medium and striking a mirror. Okay, and what is the question? Angle of refraction is equal to 30 degree. The question is that show the diagram the path of ray of light after it strikes the mirror. A monochromatic ray of light. Monochromatic means a light consisting of single wavelength. A light consisting of many wavelength. White light we call it as a polychromatic light. So white light is a polychromatic light. Please remember it. So this is the case of a monochromatic light. So it is striking the mirror. The diagram is incomplete. The first part you have to show in the diagram the path of ray after it is striking the mirror. So let us check it out how it is completed. So on striking the mirror, of course it will get reflected. So for that I will draw a normal to the point of incidence. What will be the angle of incidence in the medium, denser medium liquid? So of course it will be 30 degree, because if this angle is 30 degree, the alternate angle should be equal, that is must be 30 degree. If the angle of incidence is 30 degree, of course the angle of reflection must be, the reflected ray goes like this, the angle of reflection also should be equal, 30 degree. Alright, again you draw a perpendicular normal to the point of incidence. If this angle is 30, angle of reflection is 30, this angle of incidence being the alternate angle must be equal, so it should be 30 degree. Okay, now the ray of light is traveling from denser to rarer medium. How it will travel? It will bend away from the normal. It will bend away from the normal. Okay, it should bend away from the normal with the angle of emergence 45 degree. Alright, so the angle of incidence and angle of emergence are equal, because a ray of light, when it is traveling in the same medium, it must be traveling parallel to each other. It must be equal, it must be traveling parallel to each other, because it is traveling from coming from air and going back to the air. So what happens here also? Here is a partially it is getting reflected. So this is at the boundary of separation between air and liquid, is some amount of light also will be getting reflected. So it is getting reflected at an angle of incidence 45 degree. Alright. So this is the reflected ray. So the diagram is complete now. The angles are complete. It is very necessary to write the angles, otherwise you will not get the full mark. Okay, you can name it as O, A, B, C, D. So OA is the incident ray, AB is the refracted ray, again BC is the light, since light rays are being reversed back, BC is the incident ray and CD is the refracted ray, or better we call it as emergent ray. Okay, Now the second part of the question, I hope this is clear to you. Okay. Refractive index of the liquid, I have to find out the refractive index of the liquid L with respect to air. So that is, what is the refractive index of liquid with respect to air? Applying the Snell's formula, sin I divided by sin R. So refractive index of the liquid is equal to sine of angle of incidence, sin 45 divided by sin 30. So look at the logarithmic table, and what is the value of sin 45? It is 1 by root 2 divided by sin 30. It is 1 by 2. That I can write it as 2 by root 2. So 2 by root 2, solve it and see. Root 2, you are getting it as 1.44. So that is the refractive index of the liquid. It has no unit. So things are clear to you. So in this way, we can apply the principle of reversibility of light and the Snell's law in solving numericals. Clear? So thank you for watching.